Okay, so JPEG 1, so which is the ITU-T recommendation, ITU-T 81, and ISO IEC 10,918+, it is now 25 years old. So I will talk a little bit about the past, about the present, and about the future of this JPEG 1 standard. So first, the outline of the talk. I will be talking about the history of the early JPEG requirements. And then I will talk about the history of the first digital camera experiment of Kodak in 1975-1976. And based on the experiment, the wrong judgments of the effect and timing of digital photography. And then I will also present you some market figures on the dominance of the JPEG images in today's and also in the past photography. And also I will make predictions about the future. So the basic question is there a future for JPEG 1 standard? And then finally I will come to some conclusions. So let me get to the first one. So this is the history of the early JPEG development. Well, in the mid-1980s, so there were different projects that have led to the JPEG standardization. And strangely enough, all were driven first by the same type of projects, and people, nearly all by telecommunication applications. And the first one, it was the video text photographic mode project, both by CCITT or ITU-T and ISO, and the video text, it was a pre-runner of the World Wide Web. And that had different modes, and one of them was the so-called photographic mode, which was one of the latest development there. So the second movement was within ISO TC97, which was responsible for information technology standardization. And there was an SC2 on coding, and WG8 was one working group within that. And they had a project on picture coding identification and also code switching from text to picture coding, graphic coding, etc., etc. So that was the second project. And the third project, that was again a different project in ITU-T and CCITT. So it was a CCITT Study Group 8 project. And that was a project which was called on New Image Communication. Well, the first one was the video text photographic mode project. So as I said, this was driven by CCITT people and ISO standardization people, but basically behind it, it was the telecommunication industry, telecommunication services. So as I said, the video text, it was the forerunner of the World Wide Web in the 1980s, and that forerunner didn't have a photographic mode at the beginning. So what you see here in the middle of the slide, it was basically a graphical picture, but it was created by pixel graphics and mosaic graphics. So here we are not talking about this type of picture, but we are talking about true photographic images. And this was something in the mid-80s, just a dream, so it didn't existed. And there was a project because this video text, it was primarily running on PSTN, so on public switch telephone network, so it was a very slow network with 1200 bit in the second, and then second bit in the 75 bit in the second as backward channel and so on. But ISDN with the 64 kilobit channels, it just came into the market, and they wanted to have some additional applications on it. Not only phone calls, but also something more fancy. And they thought, okay, video text with a high speed and with photographic mode might be such kind of fancy application. So on the bottom here, you see the system names of these different video text application in different countries. One of the most advanced one in terms of video text terminals and those systems, that was actually in Austria. And in Austria, so they had an intelligent, they used basically a dedicated PC as intelligent as video text decoders. In other countries, it was much similar. It was mostly, something like a remote controller of a TV. But here in Austria, they used really a dedicated and intelligent PC, and it was called Moped. And it was an 8-bit PC computer. And here you can see the television set was as output device, and then the telephone, that was the telecommunication part. So this is out of an Austrian sales brochure. Well, one of the first photographic images via video text, via this Moped terminal, and that was done by a proprietary telesoftware, which you could download it from the central system. It is very much like JavaScript. So it was a pre-runner, I would say, of JavaScript, of ECMAScript. And it was developed by the Technical University in Graz, so by Professor Maurer and his team. And it was developed in 1982. And this was a picture of a Lapland girl, and actually it is not a very high resolution picture. So the number of colors, I believe it was 4 or something like that. But maybe in the depths of the color, it went bit until 16 different shades. So it was a sort of photographic pictures, and then when you have downloaded in a sequential manner, so from the top to the bottom, then actually over these very slow channels that I was mentioned to you with 1200 bit in the second, it took 4 or 5 minutes on PSTN to download the image of this girl. So it was not practical. Now, strangely enough, this image was also put on a sales brochure of the Austrian PTT for advertising video text. And I have to say, that this was a little bit of a cheating, because, just to wait 4 minutes for such kind of picture, this is not really a service. But this picture has been taken, as I said, out of a sales brochure. So, in other words, a good photographic mode solution was required and was needed. So this is what happened on the ISO side. So in the ISO, they were already dealing with this type of subjects, especially switching between the different text mode and graphic mode, etc. That was the prime task, but to do picture coding and picture compression and so on, it was not really an ISO territory yet. So the first series, which I take as a serious project in that direction, which I call a serious kickoff of a photographic coding standardization, it was started by Graham Hudson from British Telecom, so he was the chairman, in 1986. Before that, so Graham has already pointed out in earlier years, that this is something that we need to discuss and to do it. And actually, there was not much enthusiasm by the others, especially by the Japanese, who actually wanted to slow down this type of standardization and process, because their system was not that far away ahead, and also they didn't have too much interest in it. So this is what you can see is out of a text of a original ISO document. So everything what you can see here and also in the following slides on a white background, these were scanned from original document. So here it talked about this project which I just mentioned to you. Well, the third one was again in CCITT, so in CCITT Study Group 8. And as you know, CCITT has so-called questions, so study questions. And one of the study questions It was among the, I don't know, maybe 20 or 25 for study group 8. It was about new image communication, NIC, so new image communication project. And this question was drafted for the study period of 1985 and 1988. And the spatial rapporteur of the question was Mr. Manfred Wörlitzer from the Deutsche Telekom. And Manfred Wörlitzer was also a key figure in the standardization of video text itself, and also not only in that, but also at home at the Deutsche Bundespost in Darmstadt. So he was one of the project leaders implementing the video text and then running the video text project. So he was very, very involved and very, very busy. And my company at that point in time, it was Siemens in Munich, and I was just started to work with the standardization people there. And our role in the CCITT was at that point in time, we were advisors to the Deutsche Telekom. So we didn't really speak for Siemens, but we spoke more together for the Deutsche Telekom. And we had very, very close relations with them. And also in the area of video text. And then one day, the colleagues from the Deutsche Telekom and Manfred Wörlitzer himself talked to my boss, Mr. Pop. Mr. Pop was an excellent engineer, and they asked for help. And the help was regarding this new image communication project, because Mr. Wörlitzer was so busy that actually he could not really drive here the activities of the new image communication. So they asked Siemens that they should help with somebody else who could help with this project. And so this help was then me. So Mr. Pop came to me and asked if I could help Mr. Wörlitzer just to set up this project. So I went to Wörlitzer, and then we started to talk about the project. So my first question was, what is this new communication? What is it about? And then Wörlitzer said, well, I have not the slightest idea about it. We have to invent it. And this was the style that Manfred had, a very sympathetic, a very direct style. So we always had an excellent relationship because we just addressed things as they were. So then I said, okay, good. So if we have to make up, what new image communication, really good, then I will think about it, and then we will up with something. But what that was at the beginning, we had not the slightest idea. So then the next time, in order to searching, okay, what should be this project of new image communication, we started to work. So this is now from a 1986 CCITT Study Group 8 meeting report. So this is the report of the Spatial Rapporteur Group, so new image communication. And then here it mentions Mr. Wörlitzer, and then I was appointed as technical secretary, and then the list of participants, of course, was also attached. Maybe we were, I don't know, 10 people or something like that. And then what the agenda was, and then what were the documents that we were looking at. And as you can see, the document identified, and that we looked at it very, very closely, those were actually Japanese documents. So Commission 8, 46 by KDD. KDD was the international Japanese carrier at that point in time. And so they have proposal on coding scheme for multi-level images. And then the next one was the document 47. It was also from KDD. Then it was a proposal on progressive coding scheme for telematic services, and so on. So actually, this contribution, so they were one of the basics, that when we were trying, okay, what the new image communication could be. Then some ideas from these documents, and there were some more of them, they came very strongly from this Japanese paper. So inspiration, it was inspired by Japanese paper. The head of the group, it was Dr. Yamazaki, and he was helped by Mr. Endo. So those were the two people, I really should credit for the original ideas. Here, in the same manner, this was one of the KDD delayed contribution. Delayed contribution are in the ITU and CCITT regime, those contributions which are coming to the meeting, so not beforehand, the earlier ones that you saw that came before the meeting. So this was also another document in this study on hierarchical image processing for telematic services. So this went to a Kyoto CCITT Study Group 8 meeting in 1985. And I have taken that contribution because that I think it was a basic contribution from the idea, and it contained some important new concept that also went finally into the JPEG standardization as requirement, a very important comment. So the first one was the hard copy and the soft copy communication. So the hard copy, it was basically something like facsimile communication, you know, when it came out with a finer quality of the images and then it got printed. So that was the hard. The soft copy communication, it was more a screen-oriented communication. So for instance, in a database search, it started to build up the image, and then you could see the image on the display, and then the image maybe it got better and better. But the soft copy meant actually it was a display type of presentation. The next point, which is of course then linked to the soft copy communication, was the progressive image build-up. And the progressive image build-up, it was in contrast with the sequential image build-up. The sequential image build-up, it was you just saw it from the top. It built up line by line to the bottom. It is, for instance, typically what you have on facsimile, and it is rather boring. For instance, on a screen when you have that same type of image build-up, for instance, on a display screen. So the progressive image is that you see something with a bad quality, and then with time the quality gets better and better. So that's a progressive build-up. The quick lookup, next point, and variable image quality, it is linked together with the progressive coding scheme and progressive image build-up. Quick lookup is possible because you immediately see, even in a bad quality, what it is all about, and especially if you make that as a small image, then it looks, even from the quality point of view, quite okay. And the variable image quality means the following, that actually the quality, it gets better and better, and so it is never constant. And actually with that, I mean, you can stop somewhere also the image build-up, and with the stoppage of the image build-up at a different time, you can have, for instance, very quickly not very good quality picture, but with more time you get a better quality picture, and so on. So this is the characteristic which is built into the progressive coding scheme. And then linked to that is also the lossy and the lossless compression. In some application, lossy compression is good enough. For instance, when you when the image is built up and then you have a built image on a screen, and it is lossy. It is not exactly the same as it was before encoding and so on, but you even don't notice the difference. So there are those type of application. On the other hand, the lossless compression is that what you get, for instance, after a facsimile sending process. So when the output image is exactly byte identical or pixel identical with the input. And in many applications, so not only in facsimile, but also, for instance, in medical applications, it is of high importance, you know, that at some point in time you get this lossless compression. And image database application, I already mentioned to you. So this is, for instance, linked with the quick lookup. So this type of coding, it is especially suitable for image database application because you can see and select very quickly a small image, so quick lookup, and then if you like the image and you would like to see it, then you click on it and you retrieve it, and then you give time that more complex and a nice picture is being built up. And And interactive conferencing applications were also supported with this type of coding. But in the proposal itself, it was only first black and white only because it came from facsimile, and later on it was still one color, but with more pictured image and color depths, and then finally in the latest applications from KDT, then it was full color, which already led then to the completed the requirements of JPEG. But that was later. It was in 86, 80, 87, and so on. Now on these pictures, I mean, you can see also from this basic contribution from KDT in 1985 from a Kyoto meeting, the difference between the progressive build-up, you can see on the top of the picture. So it was a facsimile sort of type of transmission or of 9.6 kilobit per second. You can see on the top, the progressive image build-up of that facsimile image on the screen, and on the bottom how the image build-up looked up with the sequential mode. And you can agree with me that of course the progressive build-up on the top, it is much more suitable for soft copy and for interactive type of applications. Okay, so these were some of the ideas, and then we had to come to the list of new NIC applications in 1986, and this was another thing that in CCITT study group 8, you had several questions, 7 applications which used some form of images. And it was very important, and at least that was what we thought, that it is very important somehow to bring together all these applications. And here you can find the list of those applications where we wanted to have with this new image communication some kind of commonality, that they should come out with some kind of, I don't know, common component or something like that. And also it was always a very important requirement in CCIT, the interworking, so these 2 different application systems could somehow interwork with each other. So this is always a key requirement in telecommunication. So in this case, in this list, the separation was first of all low speed applications, so up to 9,600 bit per second. So for instance, video text, the classical one, then facsimile, then digital phototelegraphy. So video phototelegraphy was a standalone picture service for the news people. For that we also had standards in CCITT. And then in the second category, we had high-speed applications, so which was targeted for ISDN speed, 64 kilobit in the second. So video text in ISDN, picture transmission in ISDN, for instance, image database searches, then digital phototelegraphy, so the same thing, only at high speed, then press telegraphy, this is even higher resolution, then facsimile, then some kind of still picture image transmission mode over television sets, and then telegraphic, telematic, teleconferencing, so which was teleconferencing using screens and graphics and so on. So these were all questions. So these were all of them were one of the 20 questions. And as I mentioned, interworking was important, so there were we came to the conclusion that some kind of common components had to be solutions, and the toolbox principle. And very interesting, we didn't have a file format because each application themselves had a file format. And actually in the requirements of JPEG, then it went into that like that, without file format. And then later on, especially on the ISO applications, such as, for instance, application for PC images, it turned out that it was a mistake, and then we had to take a de facto standard file format application, which is JFIF, which then has been standardized 20 years later. It was a de facto standard. Out of this, then we came up to the properties of NIC, of the new image communication in 1986. And I just go through very quickly the pages because I have already mentioned, what is behind it. So this was out of the meeting reports, So quick lookup was important. Then adaptive selection of image quality was important. Then obviously high coding efficiency, compression rate, that was important. Obviously, I didn't mention, but it had to compete with all the compression rates which existed before, and it had to be better, especially for color images. There was no real competitor for that. This is the continuation of the properties of the need. So then one idea was, and which we could not fulfill in JPEG actually, only in JPEG 2000 later on, was the unified algorithm for black and white, grayscale and color images. So we were thinking about one compression and coding scheme for everything. So it is preferable that the coding scheme is applicable to black and white, grayscale and color images. And then in the experiment, it turned out that we had to separate later on. Turned out the color images from the black and white and from the grayscale images. So the first two components went into compression scheme, which is called a JPEG, joint bi-level image group, and then color images. So that was then the territory of JPEG, joint photographic expert group images. Next one is the application. So the application, as I mentioned, it should go to a wide range of applications, soft copy image application, hard copy image application, and then also the combination two. So it should be used for teleconferencing, for image database require, video text, etc. And then the range of resolution it has to be also extremely broad. It should be very flexible, and it should allow for a range of 400 pixels per inch at least. Yeah. So but of course, that's the maximum for a screen-oriented communication. That was much lower. So that, for instance, CCIR quality, so 725 times 580, that was already, they are high end. And then note, for press telegraphy, there is an extreme resolution up to 2000 pixels per inch necessary. So range of resolution flexible. This is the third page of the properties. So range of speed, it should be low speed and up to 64 kilobit per second. And for press telegraphy, which is very big images and a lot of data, then it was envisaged that up to on that extreme transmission speed up to 2 megabits in the second, which was the primary ISDN channel, should be necessary. Information preserving means that it is very useful that in the final progressive build-up, the final stage of transmission, for instance, when it is printed, then it should be information preserving. So exactly the information which came out from the decoder, it should be what goes into the encoder. Error sensitivity was also a requirement. Also, we knew that the transmission channel itself should care for the error, but it was more error robustness. So we wanted to have something which is to a certain extent error robust, even if the transmission channel below it has mistakes in code of terms of transmission of information. So it should be an algorithm which has error robustness. And then switching capability between copy modes. So for instance, you could start with a soft copy image on a screen, and then when the final quality comes out and you press the button, you switch from the screen mode into the printing mode, and then it comes out as a facsimile. So that was the switching capability. So then it was told already at other meeting, that basically ISO and then CCITT groups, they had an agreement to create a joint photographic expert group. This is mentioned already in many different other presentations, so I do not go into that. And the point is that the first meeting, really real JPEG meeting, was in 1986 in November 11 to 13 in Parsippany, New Jersey. And here, this is just an excerpt from the proceedings report of that meeting. What were the roles of CCITT Study Group 8, and what were the roles of ISO in that meeting and also following the meeting. So Mr. Wurlitzer was the rapporteur of the NIC group. So he outlined was on one side, and then it also mentioned that the photographic expert group from the ISO side, Mr. Graham Hudson, actually he became then the first JPEG chairman, so there was a role distribution, and we from the CCITT side, so we were more responsible for the requirements. And then so here it says, that I have presented the requirements of the NIC application, which I just mentioned to you, the characteristics and so on. So we started to work together. Now what is important, this is on the bottom of this slide, that JPEG was a standalone ad hoc group between CCITT and ISO. And at that point in time, there was no rules for such kind of joint working, because the two standardization organization only later recognized that procedures for this needed, and actually the procedures were formulated only 2 years later, no, 4 years later, in 1990. So we had our own rules. I do not want to go into that because it has been covered many times in other places. So this was only the beginning, with the formulation of the requirements, which wasn't accepted, and then the development of the algorithms started, and then we have the first selection among the candidates, and then we have the second selection of the candidates. So basically, in January 1988, we had the final selection, so we knew in which direction it would be going. It was then the DCT-based coding scheme, and then from there, it took still a very long time until the standard was finished and published as a joint text standard between ITU and ISO. Actually, it was the last CCITT standard, because then in 1992, CCITT changed its name to ITUT. And so you can see it was still a very bumpy road since then. Now on the side, right-hand side, you can see actually the cover page of the CCITT standard, which was CCITT T81, and that one came out first. Now, very interesting what has remained from these original CCITT applications of today. Well, to be honest, not much. And but the toolbox principle that we had to apply in order to bring together these different CCITT applications. So the toolbox principle turned out flexible enough that JPEG could successfully also be applied to applications that we, at least in the CCITT side, did not consider and really did not target at that point in time. So it was a little bit like, like a Rubik's Cube, the whole architecture and concept. So for instance, we didn't look at digital cameras and so on. We didn't look also on other applications. So the next chapter, the second part. So here I will talk about the history of the first digital camera experiment of codec in 1976, and about the wrong judgment, in my opinion, of the effects and timing of digital phototelegraphy. So the experimental camera, Kodak digital camera of 1976 looked like that. And it was developed by a young engineer, Istvan Sebestyen. And here on the left-hand side, you can see the camera. And so with a video camera, and then for storage of the images, it was a tape recorder, and then between the two, there was some electronics. And this is the story which goes to it. So in 1976, at the Kodak Corporate Research Center in Rochester, New York, a secret, so it was not a public experiment, a single prototype digital camera was built, and it was using, that was the task of Mr. Sebestyen, available components of that time. So only what he could find, and all the components should be inexpensive, normal components. And out of it, he should build a digital camera, and I wanted to see what it was capable to do it. And actually, no one at Kodak at that time was attempting to build a camera and to and a playback system as a product. So they really just wanted to see how such kind of camera looks like, and to make some assumptions, forecast for the future. And so it was just a demonstration in the end that has proved, in quotation mark, that digital photography was not yet there, and it will not be a long time available, and it will not be a competitor to the analog photography. So that was the conclusion of the project. Then they have put away the camera, they locked it up actually, and to be honest, that was a big strategic mistake. So they have misjudged how a digital camera in 20 years time from that would look like, and then what the impact would be. So Kodak thought that the digital photography was probably decades away. And what they used, I will tell you a little bit more about it. So they used a sensor, Fairchild CCD201, so which had a very low resolution, so only 100 by 100 black and white pixel. So that means 10 kilopixel. So ideally, they thought that for for the lowest quality of color images, you would need a 2 megapixel image. And the color would mean, of course, 3 times 8 bit per pixel, also in the image depth resolution, so as an optimal goal. And this came out, taking from some estimates regarding image quality from the lowest quality of color pictures what they had, and that was the 110 format consumer film of colors. And that was the lowest quality consumer format at that time. And so in 1976, when they made the experiment, so they needed, as I said, with this low Mickey Mouse type of images, 10 kilobit storage per image. And 20 plus years later, actually with a color image, which I mentioned, it would have been 48,000 kilobit storage needed. So in fact, there was a factor of 4,800 increase between the one which they have actually tried out and the ideal one, which they have only forecasted. So they did not have any means for that. But we thought this is what it would be needed. So this is the continuation of that. And regarding the storage of the images, so Sebestyen used magnetic cassette tape for storage. And he has found that actually there was no real size limit for his small images. And he said that actually he had enough space even to store 500 of these small images on a cassette tape recorder. But he chose just to store 30 images per magnetic cassette tape, just to make the system look a bit like the analog film systems of that time, which were between 24 exposures or 36 exposures per film. So so he didn't see any image storage problems. And also from this point of view, there was no image compression need. This is a little bit a misleading thing because, as we know, magnetic cassettes or magnetic tapes have also today the highest level of storage capacity also in archivals. So, and actually in a camera you wouldn't use for storage something like that. So the conclusion there was that actually there was no need and no use for any digital image compression method like JPEG. So everything was in a raw format. And the next very important point was that the image transmission time of one single image in 1976, for this so small image, it took 27 seconds. So it was rather slow. So if you calculate this, what would have meant to use this with a higher resolution color image of the 20 plus years later with a 2 megapixel image, so then the transmission time of one single one single image on the same tape, you know, it would have been 36 hours. So which would have been even more impractical. But even already the 27 storage time, it was impractical. So again, the conclusion was the following: that they have used the wrong type of storage device, but this is what it was available at that point in time. And also they did not use any digital image compression methods like JPEG, and this would have been needed from the very beginning, and not only for the storage, but also for the image transmission time, because if it is smaller, of course, then you can transmit it much faster. So now, what happened then in the reality? So several key components have, of course, developed in those 20 years. So like JPEG, and then actually the industry hit the 20 megapixel image point for cameras around 1999. And for instance, a typical camera of that time was a Kodak DC-280. And this was around the time when the sale of the film cameras peaked along also with film sales. So nobody cared about it. So this was 20 years later. But what they didn't recognize that also during this time, rapid development of the other key components took place. So there was a memory storage versus magnetic tape. So everything now in digital camera, goes in the memory. And it was a dramatic increase, obviously, in microprocessor power and speed. Yes, in 1976, we had just the first microprocessor. In 2000, we had already very powerful microprocessors. Then also dramatic improvement and increase in the image sensor development and technology. And also it was an impressive development in the user interface and presentation mode, like LDC display, more intelligent handling of software and how it looks like, etc. So many components have been developed during the last those 20 years, which then actually it killed the analog photography. Now, this is very interesting. Also, Kodak came to the conclusion, that the digital cameras, it will not come. And so they have locked it away. And all with these negative conclusions. To make it sure, they have made the patents. So they filed the patents of the same thing, electronic still camera, in May 1977. And actually then it was awarded, the patent, US patent, on December 26, 1978. And if you look at it, then you will find that in this patent, there were many things claimed and patented, but not the JPEG algorithm, yeah, or a JPEG type of image compression, which would have been so much needed. So on one hand, it is a little bit strange, that when Kodak carried out the experiment and they came to the conclusion that it is useless as it is for the time being, but to be on the safe side, at the same time, they have also patented the same thing, and it is a little bit of the weakness of the patent approval process that actually it was accepted. So now we are coming to the market figures, and the market figures on the dominance of the JPEG images in today's photography. Now, this is a very interesting chart, and the chart comes actually from Tommy Ahonen phone book 2016, and of course with the appropriate copyright. And then it shows you the share of the photo camera types between 1933, so from a very, very beginning, early on, to 2015. And actually, the top of the picture, the yellow one, the smartphones were cut off this, and I will show you in the next picture, next slide, including the smartphones. Because what I wanted to tell you here is the following, and it's very, very interesting. So as you can see, the Sesson camera, it came out in 1976, and then they had made the patent application. So the patent came out in 1978, and as you know, the patent lasts for 20 years. So if you look at this picture, then you can see on the gray, the gray part of the increasing, that was the analog, the analog camera world. So the analog cameras, as I mentioned to you, they grow up to 1999 and 2000. And in this 20 years time of growing, actually the Kodak patent, it ran out. So later on, when here the blue compact digital cameras are coming into the picture, then already it was the Kodak patent already expired. But here you can see that the digital compact cameras, it was already much, much larger than the analog camera, and you can also see the effect on the dramatical erosion effect on the analog camera, which basically went back, and the market collapsed by 2005. And then the second independent revolution came, basically with the mobile phones, and I will show you immediately the effects of that. So here it is exactly the same picture, obviously. Now just showing, so this big yellow peak, it is actually what happened with the introduction of the mobile phone, and also especially later on with the smartphone. So at the beginning, when the cameras were introduced into, I don't know, Nokia phones or Siemens phones, they were already big numbers, but with the smartphone, then it was even more larger. So you can see that there was a huge jump. So the estimation and all the figures are taken from the from the telephone book. So the global installed base of cameras still operational. It was estimated in 2015 to 5.8 billion units, and so it is much more than only the analog camera. So many of them were obviously parts of mobile phone where the camera part was not really used. Again, estimation of how many of those were not used. So it was said, okay, maybe 1.8 billion. On 1.8 billion, you have just the camera included in the mobile phone, but the people are not using it. So the estimation was that 4 billion are cameras which are in use. Now, which is very important, that out of these 4 billion cameras in use, only 440 million, so about 11% are standalone, so traditional digital cameras. And the majority of the cameras, so 3.56 billion cameras, so 89% of all cameras in use on the planet today are mobile phone and smartphone cameras. And as you can see on this picture, the analog camera world, also where Kodak was in business, it completely disappeared. And so it is of no surprise that Kodak itself in the early 2000s, I don't know, 2005 or 2006, so had to file basically for Chapter 11, and so basically they went bankrupt. So let's continue with the photo camera picture statistic estimation, and all these statistics, these are coming from Tommy Ahonen phone book in 2014. So there, the calculation was that a standalone digital camera uses 375 pictures in a year, which is, by the way, much more than it would be used for analog camera, because as we know, the pictures of analog cameras, it was very expensive, time-consuming, and so on, also the development. And with a digital camera, this is the nice thing. You just take the pictures, and if you don't like the pictures, you delete those, and so on. So the estimation goes that 385 pictures per year are taken by a digital camera per year. And then on a camera phone user, he takes less snaps, 259 pictures per year. So these are obviously estimations and then calculation. And with that, when multiplied across the total user basis, that produces 1 trillion, so 1,000 billion photographs taken per year by the digital camera owner. So this is a huge amount of digital pictures which are being taken. And then I have also tried to estimate that how many pictures were made in the entire history of mankind with photo cameras at all. And I came to the figures that only 5.7 trillion photographs are taken. And you can see if you take 1 trillion photographs per year, then the majority, or practically all of the pictures are actually then digital picture, and the rest of the images, the analog images also, which were taken early on, and so on. So this is only noise. So if you look at these figures, and you think about it, then really these are striking figures about these revolutions of this digital camera, and the revolution also of JPEG, which is included in the digital camera. So with this, I come actually to the final points of the presentation. So is there a future for the JPEG 1 standard? Is there a future for JPEG 1 in general? And what are the conclusions? So what are the future expectations? So what is not told exactly in the statistic or singled out, but it is obviously that close to those 100% of the picture taken by digital camera have been using the JPEG 1 standard. So I would say that all the rest, it is marginal and it is noise. So as a result, the many trillions of the JPEG images created so far, and then yet to be created, it will stay here, except those pictures that will not survive long-term storage or are deleted because they were bad. So which is another question, and of course the long-time storage and long-time archival is an open issue. Then from the practical point of view, it is very, very hard to imagine that those JPEG 1 images could also be mass converted. Let me assume that there was a new post-JPEG format invented and it was introduced. So there are so many pictures taken with the old JPEG format that a mass conversion only just to be in a different format but with the same quality, it would be completely impractical. So this definitely speaks for it that also later on you have to deal with the JPEG image format and JPEG standard. So consequently, JPEG 1, which apparently today fully satisfy average user demand, otherwise, I mean, people are rather happy with it, and all these cameras are getting better and better, and then storage capacity is not really a concern anymore, and so on. So everything seems to be fine. So therefore, it is expected that this JPEG 1 standard is expected to stay here also for picture capturing, so also for generation of picture, and I would say at least for a few more decades. Exactly how? All these type of forecasts, but for the future, as we know, it is very difficult to say. So this also means that a potential successor of JPEG 1 in the consumer area, because we already had some other new image coding method, as you know, JPEG 2000s and JPEG XT, JPEG XR, etc. But even, and these are the standardized ones, and we have also several which are proprietary ones. So they, from a practical point of view, in a camera, they must be either backwards compatible to JPEG 1 in order to present all those images, old images, or it has to implement a parallel compression encoding method, including the old JPEG method and the new method, which is then, let me assume, it is not compatible with the old JPEG 1. So JPEG 1 will stay. This is the message. Now, this was from the production side. But on the reception side, on the presentation side, so to decode and present JPEG 1 pictures will always be a requirement in the future. And this may sound strange in a digital, in a modern world. And why is that so? And the reason for that is that JPEG 1 is one of the few standards that satisfies an eternal basic human need, and namely the preservation of human heritage. So it belongs exactly in the same category like writing, drawing, sculptures, and so on. So here the difference between those are of course analog, and then JPEG is of course digital. So JPEG, the only difference is that JPEG images are digital and not analog. And of course, this nature that it is digital and analog, this imposes additional challenges, which we definitely have to address. But this has to be handled by mankind separately, if mankind does care, that it should not lose its human heritage in the future. Because this is one of the fears, that the digital heritage that we have, it will go away, I don't know, in a couple of decades. This is true if you don't do anything. And so this is a separate issue from the standard. So in order to ensure that probably, and this is another point for outlook, what has to be done, it has to be probably a governmental task, exactly like for the capturing the other types of human heritage, like writing, drawing, and so on, in museums and in national libraries, national archives, and so on. So from this point of view, we have to think about the creation of a national digital archives. So the National Digital Archive would be something, which would not only archive long-term selected picture materials, but also provide for regulation and stand for standards, and ensure that always will be equipment and software around to decode and to present the images at any time in the future. So this at the moment, it doesn't exist. If a new generation of something comes out, hardware, software, and so on, the old one is forgotten, then you are standing there, maybe of a piece of I don't know, storage material, and then you find out that your computer cannot decode it because the programs are not there, you cannot read it, etc., etc. Now, so this new organization have to ensure that this doesn't happen. But at the moment, of course, it happens. So in other words, and this is the end of my presentation. So we definitely need so what are these the some action in the future? Well, we have to ensure that reliable means for long-term archival and digital information, including of digital storage images, with the quality of a digital Rosetta Stone is ensured. And here you can see at the end, also the analog Rosetta Stone, and the analog Rosetta Stone is several thousand years old with 3 different languages, and this is the way, and this is what this is exactly the same thing what we have to achieve also in a digital age. So with that, I come to the conclusion and to the final slide of this presentation. So the JPEG standard and the JPEG images, they will not go away. And they will stay here, I would say, as long as the human mankind is staying here. And this is rather strange, especially if you talk about ICT standards. And even popular other standard, ICT standards. So for instance, the mobile phone standard, the 2G, 3G, 4G, 5G, and standards. So these are generation of mobile phone standards. Well, they will go away, but JPEG 1 will not go away. A TCP/IP, which is the basis of our internet, it is a very, very strong standard, wide implementation, etc., etc. But at one point in time, probably it will go away and it will be replaced by something else. But JPEG 1, it will not. And with that, I would like to end, and thank you very much for listening. Well, this is just some description about the analog Rosetta Stone. I have taken it from a Neurouse 2013 web page, and it describes what the analog Rosetta Stone was. You can find it, you can read it, and it is now already for more than 200 years in the British Museum on display, and it is one of the most visited objects in the museum. Then this famous photo picture it was taken in January 1988 in the JPEG selection meeting. So when we have arrived to the DCT-based JPEG solution, and it was done in Copenhagen. The group itself, it was much larger than the JPEG group because also computer graphic, other WG8 people have joined it. And but most of these people have been taken part in the tests that have made their selection. But the development base, or the standard development base, it was smaller. So you can find here, for instance, Graham Hudson sitting, John Mitchell and also sitting, and then the others, Yamazaki and standing actually next to me. So I was, you can also see me here in the white shirt in the second standing role. Richard Clark next to me, Steve Urban was next to me, and then still Richard Clark, etc. So this was a famous picture. Well, this is on the other side of the picture. It was just the autograms, so the signatures of those CCITT and ISO experts at the January JPEG selection meeting. So it is a photo of the attendant signature. So very famous picture and very famous signatures. So that's all.